Hello, my name is Julianne Warmerdam. I'm a team leader for CSU Fresno here in California. My team members here are Yulissa Miguel, Victor Oscado, Justin Penley, Jim Higgins, and Hunter Eldridge. So for our presentation today, we're going to start out by going over our field methods, which is going to include setting the boundary, setting control, and then running a level loop, and then also running a topographic survey. Then we're going to go over our office methods, which is going to include calculations, reducing the data and inputting it into AutoCAD, and then creating our final map that we have on the back wall here. Next, we're going to discuss some sources of error, which seem to be quite abundant in this experience, but it was a good learning lesson there. And then some of the further challenges we had, and we'll conclude with reflections that what we learned from this entire experience. And on that note, I also want to thank NSPS for putting on this competition. It has been quite a challenge, but I've learned, and my team as well have learned so much from this. It's been hard work, but a very valuable experience, so thank you for providing that for us. I just wanted to mention a little bit about our team structure. We didn't set a particular team structure in the beginning. We kind of wanted a fluid dynamic, so when people had an expertise, they could step in and fill in to that spot, and then every time we did make a decision, we would discuss it with the whole entire team. And if one person didn't understand what we were doing, then we would explain it over again. So we were always collaborating and never left anybody out of any of our decisions. And on that note, I want to pass it on to Yulissa.
So we started off by adjusting our compass for the given magnetic declination, which was 11 degrees and 42 minutes. Once we arrived at our parcel, we set up the tripod over the given center point and then mounted the compass using a plumb bob. In doing so, it made it easier to take any measurements involving our center point. As you can see in the picture, we have our team measuring a line from our center point, and Hunter, instead of worrying about the compass, holding the steel tape, and the plumb bob, she's only worried about holding the steel tape and the plumb bob. So, we then established our north boundary by calculating our distance between the center point and our assumed north boundary, based on the 1 squared acre given. We then rotated the compass 180, then repeated the process until we established our south boundary. Once we determined our north and south lines, we then calculated our corners by using the Pythagorean theorem. We did that to determine the hypotenuse distance and proceeded to measure both our north and hypotenuse lines until the arcs intersected, as you can see in that photo right there. We then checked our assumed corners by rotating the compass 45 degrees, using the rod for our line of sight, and measuring back to the corners again. We continued to establish our east and west boundaries, by measuring the distance of our center points and corner points to our assumed east and west midpoint boundary. We finished by verifying our boundary and had a misclosure of 0.3 feet along the west boundary. With the error, we split it between 2 segments. I'll go ahead and pass it on to Victor, where he will be talking about our secondary control points.
So when we created the corners, the top, the middle, and the southern bottom, there was 9 primary control points. From those, we brought it in and we scattered 20 secondary control points. What we did in order to figure out horizontally was we swung ties from the 9 primary control points. We established these 20 secondary control points as NSSDA procedures in order to figure out how close we were to the DTM that would be created, which was our tensions. And then from there, we learned that Swing ties are way better when they have a better geometry versus being straight on line, so you kind of want them at 90 degrees. And something that else we learned was having 3 ties would be very well better as the project went on, but due to time constraints, we were unable to do a 3rd tie. Something else that we learned, or I learned as well, is you really shouldn't depend so the whole east side of the boundary was using the outside boundary control points. As soon as we got to the west side due to time constraints, I made the secondary control points dependent on one another. So if there was ever measurement bust, the whole left side would be, we wouldn't be able to use it, but luckily with good field notes, we're able to negate that. Now I'd like to pass it on. Justin.
So after we set our 20 secondary control points, we started the level loop. We backsided and foresided all the primary control points while side-shotting the secondary control points to gather an elevation for those. And so we did this around the loop, and around 3/4 of the way through, we changed out the instrument person to gain more experience, more field experience for our crew members. And so after we finished our loop, we had a misclosure of around 1 foot. And so we got together as a team, and we were like, okay, this is awful. You know, 1 foot is a little bad. So we got together. We were wondering, okay, it must have been a blunder. Someone must have read the rod height wrong. So we went back. We backsided the center point, and we foresided the corner point, the midpoints. And so we did that. We started checking. And we went down to the southwest corner point, and that one was very good. And then we then did another foresight on the midwest point, and we found a foot error. So we then concluded that it was a blunder, and we adjusted and fixed the rest of the level loop, and we had a new disclosure of about 1/10 of a foot. Now I'd like to pass it on to Jim to talk about our topo.
Okay, so for the topo, what we decided to do was to break up the parcel into quadrants. We had a lot of undulated land in the area. We couldn't just do it in a grid fashion. So we decided, once again, to break it up into quadrants so we could map each section concurrently. We started at the northeast corner and worked our way clockwise around the project, getting good elevations off of backsiding from the benchmark to those points, and then swing ties to our known control points throughout the project. Excuse me. And then like they said earlier, we had a misclosure of 1/10 of a foot. We were able to divide that up and spread it out to help balance everything out. With that, I'll pass it on to Huntress, our mapping area.
Okay. So at the end of the field day, we had about 15 minutes left over, and we decided to check the distances around our boundary one more time. So once we got to office day, we were able to adjust the bearings around the boundary using these distances, since we can only go off our distances and didn't have the bearings for the boundary line. We did this by holding the bearings and distances for the bases of bearing line and the line from the east to west midpoints, as we checked these with the compass from the center point. We adjusted the corners by drawing circles with radii of our measured distances from each midpoint and using the intersections as our new corner points, thus adjusting the bearings. Even with doing this, we were still able to get our bearings within 12 minutes of what they should be, and our distances about 3/4 hundredths off. Using the adjusted primary control points, we used our measured tie points to draw circles with radii at those distances and place the secondary control points at the intersections. As Victor said, this can create a challenge for us because we have 2 intersections and don't always know which one is the correct one. We attempted to avoid this by putting approximate direction of where the point is in relation to the tie points. We used the same method using both sets of control points to set our topo points, and this set our horizontal locations. We then adjusted the boundary misclosure of 0.112 feet from our level loop using Excel. We distributed the error through each primary control point and adjusted the elevations based on this. We used these elevations to calculate the elevations of our secondary control points and topo points. We then created a surface with a 1-foot contour, and Victor will now go over how we calculated the precision.
So, calculated precision, our precision was 1 to 1320. We had a 0.632 feet in this closure. And the way I calculated that was holding that center point and going northwest 10 degrees, which was our bearing, and then go roll. And then from there, using the calculated distance. And then after that, I would rotate that line and then draw a circle, and I would extend that or trim that using the distances that we measure out in the field. Again, and I would go that all the way around our parcel. And once we got back to the beginning, that's how we got our disclosure, and that's how I calculated it. And using that distance, I also calculated our precision. I'd like to pass it back to Julianne.
So out in the field, we had quite a bit of sources of error, it seemed, partly due to the new terrain, the windy conditions, and also because we're using a lot of new equipment that we really haven't used. Even if we had practiced with it before, we don't actually have extensive knowledge of how to use it and intuition on how to handle issues with it. So that made us have to be a little more creative in how we took care of this project. So one of the sources of error was in the magnetic compass. We noticed that when we were using the compass, that sometimes the needle would start swinging and we didn't know what it was coming from. We had checked our tripod, that didn't seem to affect it. One of the things, somebody had a bracelet on, which ended up having some metal in it, we had to take that off. And then another time I was using a mechanical pencil, which turned out to have a metal in the tip of it, which was affecting the compass as well. So I had to make sure I wouldn't try to point with my pencil to keep that as an accurate reading. So using the steel tape, of course, in the wind, pulling long distances was difficult. Sometimes we were able to put people on line to keep the wind from having the steel tape bowing too much. So that helped mitigate a little bit of that steel tape error. And then with the sag as well, pulling long distances, we didn't have a pound pull, so we weren't sure how hard we were pulling. So we didn't end up calculating that error. We just tried to pull as level as possible out there in the field. We're also using plumb bobs, which we haven't really used in the past, which aren't too complicated, but with the wind blowing constantly all day, it's very difficult. So when we had enough team members to do it, we would try to stabilize the plumb bob just by holding it a little bit and kind of pulling it back so it wouldn't swing around in the wind. Another thing, of course, was the vegetation, and it was actually quite spiky vegetation. I know I bumped into it a few times, which was a little painful, but that wasn't too bad. And so when we were trying to pull our steel tape over these, we'd also encounter problems with trying to keep it above the vegetation or moving the vegetation over a little bit to try to mitigate some of that error as well. And there seem to be a lot of plants in our area, which is probably true for everybody's area. So pretty much every measurement we were dealing with that vegetation in our way. Loose terrain as well, which some of you mentioned, we put our nail in and assume it was okay and then come back to find it's actually tilted over. So we would try to set it up in such a way where it wouldn't fall at every point, try to set up rocks and like dirt and things to keep it going, and so it couldn't really fall out of place in that loose terrain. Another thing is communication was difficult with the wind as well. The wind is pretty much one of the major factors out there. We were trying to, we would have to yell at each other quite loudly to hear, and we would often repeat measurements if we weren't sure what we were saying, because writing one number down can throw off your entire set of data. So we made sure to have a good relay of communication for our data. And toward the end of the day, we came to quite a time constraint. So at that point, we were trying to get all of our topo data, our topo points set. And as we got closer to 5 o'clock, we were rushing and rushing. So that added to potential errors where we were no longer able to be as careful as we would like to be simply because we want to get all of our data finished for that day. And on that note, I will pass it on to Victor for some reflections.
I would just like to say, I think this experience has definitely humbled myself and my teammates, especially if you were to go to a country where you don't have the latest and greatest technology, and where we have to rely on the basics of our profession. And looking back, reflecting on where our profession has come from and where it will go, we will find out. Thank you very much, and I'd like to open up the floor to the questions.
Judges, questions?
Oh yeah, I had one. Can you go over again the purpose of the secondary control points? It was a little fuzzy on their use and
I want to use the secondary control points. I wanted to use the secondary control points as check spots for the DTM and see how well they were or how close they were to the contours. That was our intentions for it. Unfortunately, time constraints and whatnot, we're unable to prove that where we shot horizontally, that's where the DTM, that checkpoint will go.
Okay, was there any of the secondary control points that were usable, or you just end up throwing out all of them?
Oh no, we still had a horizontal, and they were part of the actual topo.
Okay.
Except for one point, because the nail came out towards the end of the day, so we scratched that one. But yeah, they're part of the DTM.
Okay, gotcha.
Any other questions? Oh.
You mentioned taking side shots. Was that with the compass and?
So when we all right, so when we decided to do our side shots, when we did a tie, we did our side shot, we got an elevation for that point. Then we tied it from the primary control points with 2 ties, and then we did, because we only did 2 ties, there would be 2 intersections, so we did our best judgment on a direction towards the point that we thought it most fit, and that's where we brought it back to the office.
Thank you.
Any other questions?
Judges, any other questions, judges? Okay, audience, any questions? Oh, we got one over here, go ahead.
How many turns was your level loop? How many turns was your level loop?
So we did one setup for every single point, so we had 9 points. Apologize. We had 9. So we had.
All right, so we had 9 points for our primary control, so we set up in between each point and worked our way around. If that answers your question. And we did the same for the secondary.
I was a little fuzzy on why the grid system would not work on your parcel.
There was so much of the undulations with the washouts or little, like a small riverbed or whatever it might be at one time, whatever you call it, it just wasn't we felt it was better to get the topography better.
Any additional questions? Okay, thank you very much.